Welcome to RGES Algebra 2. This is lesson 32A. We're going to begin with the Psalms, Psalm 95, 1 through 7. It says, "O come, let us sing to the Lord. Let us make a joyful noise to the rock of our salvation. Let us come into his presence with thanksgiving. Let us make a joyful noise to him with songs of praise. For the Lord is a great God and a great King above all kings, or above all gods. In his hand are the depths of the earth, the heights of the mountains are his also. The sea is his, for he made it, and his hands formed the dry land. O come, let us worship and bow down. Let us kneel before the Lord, our Maker. For he is our God, and we are the people of his pasture and the sheep of his hand." And I want to stop right there, and we're going to look at several exhortations that the psalmist is calling us to do in the first part of this psalm. This might not be an exhaustive list, but it certainly is several of the things he's asking us to do. He tells us to come, stop what we're doing, focus on something different, sing, be joyful, be thankful, worship, bow down. Bow down means yielding our obedience. And declaring that he's the one we are following and not we ourselves. So all of these exhortations are given to us in the beginning of the psalm, and it interweaves this with several ideas on why we ought to do this. First thing it says in verse 3, it says, "For the Lord is a great God and a great King above all gods." So he is great. In verse 4 and 5, it says, "In his hands are the depths of the earth, the heights of the mountains are his also. The sea is his, for he made it." Later in verse 6, it says, "He is our maker." So because he is the creator, we're to do these things. And then finally in actually the end of 6 and 7, again, he has the idea because he is the creator, we are his. Okay? And we are the people of his pasture. We're his people. He is our God. Very personal, this relational aspect. And for all these reasons, we are called to bow down and worship him. Now, what he's saying at the beginning here, again, is come. That means not just on Sunday do we worship him by singing a few songs and then we live out our whole life apart from him, and next Sunday we come back and, oh yeah, we think about you again, Lord, and by the way, thank you for the things you've done. No, this should be a constant state of our hearts. Every day we should have the attitude. Why? Because he is first. He should be first place. He deserves to be first place. This is what we're talking about here. He's worthy to be first place. So all of this is a proclamation of worship. And to worship means to declare the worth of someone. To declare his worth. And so he is worthy of declaring his worth every day. The psalmist David says it in another psalm. He says, "One thing have I desired of the Lord, and that will I seek after, that I may dwell in the house of the Lord all the days of my life, to behold his beauty." See, to declare it, right? So this is a wonderful psalm, and I just want to exhort you as I exhort myself. Do you take time? Do you pause during your busy day, busy life, to take time to declare every day how grateful you are, how thankful, gratitude not just for the answered prayers he gives you, but just for who he is, and that he desires, that he loves you and desires to be close and intimate with you. So I encourage you to do that. Take time today to do that. Now let's go ahead and look at our answers on 9.3. I'll read them off and show you a few more examples here. Now, if you recall, 9.3 is a review section because it's all on factoring when we have a quadratic equation. Quadratic means the highest term is going to be your squared term, right? This is a quadratic equation. It's an equation because of this. It's quadratic because of that highest term. Okay, if we had an x cubed, it would not be a quadratic equation. It would be something else. Okay, so let me read your answers. It is 1 through 30 all. Y equals 4 or 3. X equals 0 or negative 5. X equals 0 or 3. Number 4, y equals 11 or negative 10. Next, x equals negative 12 or 10. Number 6, y equals 24 or negative 4. And we're finding each of these by making sure we're factoring binomials. Now, beginning with number 7, we have some inequalities. And so number 7, x equals negative 4 or, x is less than negative 4 or x is greater than 3. We have to decide if we calculate for the values negative 4 and 3, and we have an inequality. Recall we do the number line. We have 3 sections. We have to figure out, is this true or false, right? And in this case, these are true and these are true. So that's why the answer becomes, it's not x equals negative 4 and x equals 3 because you have the inequality, but it's because this is the true and this is the false and this is the true to the right, we have x is less than negative 4 and or, can't be both, or x is greater than 3. So that's how you decipher those kinds of problems. Again, number 8, x is between, it's greater than or equal to, greater than or equal to 0 and less than or equal to 5. So in this one, when you figure out your answers, excuse me, 0 and 5, and we have equal to also, so they'll be closed here, right? We know that this is the true in between. So here we said or. This is just a part we haven't gone over a lot before, but we did last time, but I want to just reinforce this. And here we say and. It's got to be between them, so x is greater than or equal to 0 and less than or equal to 5, or we could write that one this way. I won't explain each one with that much detail. Number 9, x is less than or equal to 0, and it's greater than or equal to 0. Greater than or equal to 8. I'm just going to have to go back and do number 9 for you. Okay, number 10, x is less than negative 3/4, or x is greater than 3/2. Number 11, n equals negative 6 or negative 5. The equals are easier, right? We're just doing those binomial factoring. Number 12, c equals negative 18 or 2. Next, L equals negative 17 or 2. Next, R equals 15 or negative 9. Number 15, x equals 8 or negative 4. X equals 1/2 or negative 2. X equals 1/3 or negative 4. R equals 6 or negative 5. Number 19, x equals 1/5 or negative 2. X equals negative 2/3 or 3. X equals 1/3 or 1/2. X equals 0 or 3. Number 23, x equals 2/3 or 3/2. y equals 7/9 or negative 2/3. S is between, so it's greater than negative 4/3 and less than 1/5. Number 16, A is less than 4/3 or greater than 10/3. 27, X is less than or equal to negative 4 or X is greater than or equal to 3/4. And number 28, X is negative 1/6 or 2. For the word problems, 29, the length is 8 inches, that's an L for length, and width, that's inches, is 6 inches. And for 30, the numbers are 15 and 13, or negative 15 and 13, or 15 and negative 13th, you can kind of guess the last one, or negative 15 and negative 13. Okay, so all four of those possibilities. Read the problem over again, you'll probably understand that. If you got the numbers 15 and 13, all you got to worry about is all four of the combinations. All right, so let me go and do a couple of those. I won't belabor this because this is a review idea, but I'll give you a few examples. So to solve these quadratics, the first thing we want to do is go ahead and set the equation to 0. It is an inequality rather than an equation technically, but go ahead and set it to 0 nonetheless. You'll get 2x squared minus 11x minus 5x. In this particular case, these will combine. Oops, I'm sorry. Greater than or equal to 2x squared minus 16x. We're going to go ahead and factor out a 2x, leaving me with x minus 8. And so my two answers are going to be 0. Remember, it's either that equals 0 or this equals 0. So this will be x equals 0. We're just solving for the equality right now, or x equals 8. Then we need to graph these. Breaks up into 3 sections. And we want to know when it's greater than, right? So if we get a negative 2, let's say, and we plug that in, let's plug it in here. It's a little easier. And so we're going to get 4 times 2 is 8 plus 22. That'd be 30 minus or plus 30 plus 10, right? And that is definitely greater than. Let's pick out 1 over here. Let's pick out 10. So plug it in. I'm going to get 200 minus 50. That'll be 150. Is that greater than 110? Yes. Let's just make sure. Plug it in the middle region. I'll get 4 times 2 is 8 minus 10. That'll be negative 2. Is that greater than or equal to 22? Sure is not. So what does that tell me? My answer is going to be, the original was greater than or equal to. So because we have the or equal to, we'll include the point. So this is false. So x must be less than or equal to 0, or, so we'll go that direction, or x is greater than or equal to 8. Now, it's funny because they wrote actually and in there, and I paused and said, I better do that one for you, but that's not true. It's not and. It can't be and, because these are in opposite directions. Okay, so that was just a mistake in the book. It's got to be an or. when we read these. All right? Because the point over here doesn't include, how do I want to say this? It's not going to include a point over here. Okay. So, all right. Let's go ahead and do a couple more. Now to do this one, we're going to, let me make sure I got that copied right. Yeah, okay. We're going to distribute, and we're going to take this to the left-hand side, making the right-hand side 0. 6x squared minus 13x plus 6. I also reordered it. Now, can I factor this? So I'm writing the factors of both the first term and the last term, and the only way I can combine those in such a way is if I combine this one and this one. Is that obvious to you? Because that would end up being 4 and 9. And if they're both negative, we'll have 13. Okay. So, now what do I always tell you? Check this step. FOIL it. Does it work? First term, 6x squared. Outer is minus 9, minus 4. That would be minus 13. And last term's positive 6. Yes, it works. Don't move past this until you make sure you've checked with FOIL to make sure that when you've factored your binomials, it works to the equation above. Now, set it each to 0. This would, I'd put the 2 to the right side. What I mean by that, remember, some of you are having a little bit of trouble there. I say either that equals 0 or that equals 0. Take this to the right side. You'll get 3x equals 2 or x equals 2/3. Take this to the right side. You'll get a positive 3, 2x equals 3, or x equals 3/2. So those are my two possibilities, and that's the answer. Okay, this isn't just an equal sign, so we don't have to worry about that last little bit. I'll just write down your equation for the word problem. It says the area of a sheet of cardboard is 48 square inches. And so we have length times width. The length is 1 1/3 times the width. So if we have length, that is 1 1/3 is the same as 4/3. Length times width equals 48. So you're going to have just a squared, right? 4/3 w squared equals 48. Multiply the right side by the reciprocal and take the square root. The sum of the squares of two numbers is 394, and the difference of their squares, so what's the sum of the squares? X plus y. What's the difference of the squares? X minus y. And the sum of the squares of two numbers. Okay, so we've got the squares hang on one second. Went a little too fast at that one. Let's try it again. The sum of the squares. So there's the square and there's the sum. So the sum of the squares of two numbers is 394. The difference of the squares is 56. There we go. So I would just tend to actually solve for x squared in this one and plug it in as for x squared. But there are a couple different choices you have, and you should get the two numbers as, I think I'll just go ahead and do that. I'll do this one for you. I'm just going to go ahead and do it by linear combination. We'll get 2x squared. The y's squares will cancel out. We'll subtract there, and we'll get, we're actually summing this, and we'll get 450 divided by 2, x squared is going to be 225, and when you take the square root, x will be plus or minus the square root of 15. And that's why you're going to get those 4 combinations. When you plug that back in then to solve for y, you're going to get y equals plus or minus 13. Now that you might not realize that that represents 4 possibilities, but it does, because if I have it's plus or minus. So if I have it's plus, it could either be a plus 13 or a minus 13. Then if I have a minus 15, it could either be a plus 13 or a minus 15. And that's how you interpret that problem. Okay, I'm going to stop here and do a part 2 to present the 2 new ideas.